Okay, so in this second part of the video, I'm going to show you how to do a model, a harmonic response. So there is a model for harmonic response in your toolbox, just drag it in. Okay, so again we have some harmonic response steps, but firstly we want to share the geometry, so we can easily do that by just drag the geometry into that, so it's tick. And then we just go into the model. In that model, similarly, the first step is to define the mesh. So the mesh, we just use the same size. Alright, now we have meshed our model. Then we just need to define again the support or the boundary conditions. So this time we want to have two different boundary conditions for each node. So because later on we're going to look at the bending stiffness on these node points. Then we want to set up the analysis. So basically we want to look at the range of the frequencies. So we say from 0 to 30 Hertz, and we do 300 intervals. And okay, then we want to define what we want to plot. So firstly, we want to have total deformation as we had before. And secondly, we want to have some moment reaction on the boundary conditions. So we want to have moment reaction on the fixed support, and probably we want to have another moment reaction on the second fixed support, so which is here. Also, we want a frequency response in terms of deformation, and so we want to have the deformation of this node. Alright, so that's pretty much all we want, and we can solve it. You'll just take sorry. Oh yeah, sorry. Before that, we also need to define the load. So load is defined by this, the load and the force. And the force is applied to a point, so which is this point, and apply. And the force can be defined as components, so we can easily define the Z force, which is 500 Newton. So you see the force is defined, and we should be able to solve it. Okay, so that's your spectrum analysis. So you see that's the amplitude frequency response, so frequency from 0 to 30 Hertz, and we have quite a few peaks, and as we know they should representing all the modes. And if we look at the bending reaction, we also see those peaks, and we can pick up one of the peak and plot and retrieve the data. So we can see this is obviously one of the mode we found previously. So that's our first mode, and if we remember, that's our second mode, and that's our third mode, and that's our it's not actually a mode. Yeah, that's our one of the mode again, and that's the mode. So So that's your harmonic response. And again, that's the phase you have, so from 0 to 180 degrees. And that two beams gives you similar response. So that's your harmonic response.